No. Okay. So I hope all of you have run the fast QC, the quality check step for the samples. Is it done, everybody? If any doubts are there, you can ask me. I'm sharing my screen and we are remaining with the explanation part of this quality check. So let's go for it and then we will go for the next steps. So basically, now I will share my screen. Just give me a minute for that. Yes. I hope you are able to see my screen. So here what we are having this HTML file. I just have told you like yesterday only that the FastQC will give us one HTML file and one zip folder it is going to give us. So in this HTML file, you will be having the graphical representation of this FastQC report. And here in this zip file, we are going to have the summary of that report, right? So let's open this _1 or the forward file FastQC report and let's understand the concepts. So can anybody please tell me, yesterday I have told you there are three most important parameters which we need to consider here. So what are those parameters? Anybody remembers that?
For base sequence quality, over-represented sequences, and adapter.
Yes, exactly correct. That's correct. So let's try to understand the parameters from here. And as I have told you yesterday only, if green colored mark is there for your particular parameter means what? It is representing the good quality data for that particular parameter. If you are having a red cross mark means you are having a bad quality data for that parameter. And if you are having the yellow exclamation mark means you are having a moderate data for that parameter and you can still proceed with the data. Now here the first important, not an important one, but yeah, we are having the first parameter as a basic statistics, in which here you can see the basic statistics is being mentioned. So you are having the measures and the values over there. So first is file name. So file name in the sense for which file you are checking the quality, that file name will be mentioned in the value. Then we are having the file type, which is conventional base call method. Means like they have used the actual base calling method while performing that sequencing likewise. Then we are having the encoding. Do you guys remember what do you mean by encoding? Anybody? Okay. Encoding is nothing but conversion of your Fred quality score into the ASCII characters, right? In the FASTQ file, you are going to have the Fred quality score in terms of ASCII characters in the fourth line itself. So that encoding is being done with the help of the Sanger or the Illumina 1.9 platform. So that is being mentioned over here. Then we are having a total sequences, means total number of reads which are present in our sample. That count you are having it. Then you are having a sequence flagged as poor quality, means out of that many total sequences, there is no read which is having the poor quality. So we are getting 0 number. Then we are having a sequence length, means most of the reads are having the length of 151. So that is being mentioned over there. Then we are having the GC percent as a 47. So yes, GC percent actually represents the stability of the basis, right? Stability of your data. So that is what again we are having the cutoff between, it should be between 40 to 50, and that is great again. GC percent also we are having within the range. Now let's go for the next part. That is what our first important parameter, that is per base sequence quality. Now I will zoom it bit in. Yes. Now here you can see in this x-axis you are having the position in the read, and in the on the y-axis you are having the quality scores across all bases, or you can say the Fred quality score, right? So here again your y-axis is being divided into the three sections: green colored zone, yellow color zone, and the red color zone. So if your quality of the basis is falling under this red colored zone, means what? Here you will be having a red cross mark. If your Fred quality scores are falling under this orange color zone, means your bases are having a moderate quality. Still you can proceed with the data. And if your bases are falling under this green colored zone, means what? Your bases are actually good. These are actually called by the machine properly, as the Fred quality score will be above 28 or it will be above 30. So that is representing the good quality data. Now how you're going to interpret it? So here you will be having the box whisker plots. Here you can see one box whisker plot is being given. So whenever you want to provide any kind of range to any values, then this box whisker plots will come. It will be representing the lower limits. It will be representing the upper limits of your range, which can go further, right? Mean and median is being also mentioned over here. Now, if you will see, this box whisker plots are falling under the green colored zone only for our data. So that's why here they are representing the red tick mark, which is good symbol, right? So we can proceed with the data. Is that clear? And as we know, Fred quality score, if you're having greater than 30, means what? Your bases are called by the machine accurately, like it's 99.99% accuracy is there. So yes, you can go for it then. Per base sequence quality parameter is good for our data. So shall I move to the next parameter now? Because this was the important parameter. So if you are having any doubt in this per base sequence quality, you can ask me. Clear. Okay. Only one student is responding. What about the others? And I hope I have started the recording. Is it? Okay, he said. Okay, okay, fine. Let's move to the next parameter. Yeah. Thank you so much for responding. Let's move to the next parameter now. So the next parameter, we are having a per sequence quality scores. Here in the second parameter, you are having per base quality, and here you are having per sequence quality, means how your sequences are actually there. So now here you can see in this particular graphical representation, on the x-axis, you are having the Fred quality scores. Again, we know that Fred quality scores are like if these are greater than 30, means actually these are better one, right? Then here on the y-axis, you are having the quality score distribution overall your sequences. So actually we are having these many sequences. So in these many sequences, how your Fred quality score is actually varying. So that information or that graphical representation is provided over here. And now if you will see, the graph is taking the peak, but it is after the 30 Fred quality score only. Before the 30, we are just having a smaller inclination, right? We are not having much difference over there before Fred quality score 30. So as this graph is taking the peak after the 30 Fred quality score, means again it is representing the good quality, right? So yes, that's why as the graph is taking peak after 30, so your per sequence quality scores are also showing the green tick mark, which is a good symbol, right? You can proceed with the data. Then we are having the next parameter as a per base sequence content. So here in this per base sequence content, we are going to actually know how ATGC bases are distributed in overall our sample. So that's why in the x-axis, they are giving you the position in that particular read, and most of the reads are having the 157 length, so that's why till 157 it is provided over there. Then we are having the sequence content across all the bases. Now here further, so our adenine, thymine, cytosine, and guanine, these are represented in a different colors, like thymine in a red, cytosine in a blue. So these graphs are being provided over here. So if we get a normal lines from zero to last, it means that our bases are equally distributed in our sample. But currently, if you will see, we are having certain what you can say, we are having bit random distribution till ninth position, right? From here, your graphs are similar, but here you are having somewhere a random distribution, but still it's fine. Even though the random distribution is there, but it is not having much difference. So that's why still your per base sequence content is also good. You're having a green tick mark for that. So whenever the green tick mark is there, no need to worry about that parameter. Okay. And again, this is not our most important parameter, then you can neglect that particular part. Okay. So then we are having the per sequence GC content. So now for every organism, actually, like GC percent content is already known. So for Homo sapiens, or maybe if you're taking in the data for any another organisms, for them only we will be having the GC percent already known. So that is represented over here in this blue colored line. And this red is like it is interpreting ours data, our GC count from our sample, right? So they are just comparing the actual GC percent and our sample GC percent, and this is having so much difference in between these graphs. Like here you can see a lot of differences there. Here also the points are having a lot of difference. So that's why here you are having a red cross mark. But still again, as I have told you, our main important parameters are three on which we are going to focus. So even though this per sequence GC content is having the red cross mark, we will not focus on it. But just for your extra information, I have told you the thing. Okay. Then we are having the per base N content. So what do you think? What can be this N content? Can anybody please tell me? What can be the N content? Null. Okay, null in the sense for what, like? Okay, missing. Okay. So actually what happens sometimes during the evolution, if some bases are getting changed, so that bases are not identified by the sequencer machine properly. So it will be not able to sequence that basis, right? So at that time, it will represent that basis as a N, which is gap. Okay, it is not able to identify that basis. And obviously, if any gaps are present in our data, that is not a good what you can say, that is not a good data then, right? If you're having a lot of gaps into your data. But now in our data, we are not having any N content. As you can see, this red color will be representing the N content gaps. But here our graph is not taking any peak. It is at the zero level only, right? So that's why we are not having any gaps also in our data. That is representing the good quality. Okay. Then we are having the sequence length distribution. So as I have told you, like most of the sequences are having the length of 151. So here our graph is taking the peak at the 151 only. So here we will see like how our sequence length has distributed over all the sample that are that we can see it here only, right? In between 150 to 152 only our sequences are having the length, right? Because there should not be any random distribution, like one read is having or one sequence is having the length of 90 base pair and another one is having the 147 or something like that. There should not be so much of differences because it will further lead to the false results. So that's why uniform distribution of your sequence length should be there. And that is what we are having in our data, as we can see the graph is taking the picture. So that's why here again we are having the good quality for the sequence length distribution. So that's why green tick mark is represented, right? Then we are having the sequence duplication levels. So if any duplicated sequences are present in our data, a lot of time duplication of the sequences is happening. So that is not again a good symbol for further or taking that data. That is also not good quality data over there, right? So there should not be any duplicated sequences also in our data. So here you can see already this blue color graph is indicating the total number of sequences and red color is indicating the deduplicated sequences. So yes, there are the lot of difference again in the theoretical and the deduplicated sequences, like how actually it should be and how our data actually is. There is a lot of deduplicated means what? Like whenever amplification process is being performed, if your sequence is getting duplicated a lot of times, before also it was duplicated. See, if one sequence is there, it got duplicated, and after the amplification it is getting deduplicated multiple times. Okay, so if only one time that sequence should be there, but it is duplicating a lot of times, isn't it? So again, it will give you the false result. So that's why this duplicated or the deduplicated sequences should not be there. So that's why here in our data, we are having that deduplicated sequences. So that's why here we are having a red cross mark. So how you are going to remove that? So that deduplicated or the overrepresented sequences are going to be represented in this section. Okay, so from here we can trim it out. But again, even though red cross mark is there, we are not going to focus on that parameter, right? Now let's move to our most important parameter, that is overrepresented sequences. You can open the FastQC report for the first sample, for the forward sample into your system, and you can check this out, okay? Overrepresented sequences, what I'm explaining you now. So here in the overrepresented sequences also we are having the four columns. So these many sequences are there which got overrepresented in our data, but no need to worry about it because no need to trim these many sequences. As I have told you previously only while introduction part, that if your sequences are getting overrepresented or if you're having any outside sequences into your data, that is representing the bad quality, isn't it? So here that outside sequences will be represented in this particular parameter that we need to trim it out, right? So now here, which sequences we have to trim it, that is also important because there is no need to trim all those sequences. So whenever you are having any sequence here, which is represented, but here the possible source is no hit. Okay, so if no hit is there, means no need to trim that data, that sequence. That is totally fine. Even though it is present in your data, that is not harmful for your data. It is not going to give you the false results. But if you are having any another possible source rather than the no hit, then you have to trim that sequence. Here you can see you are having the no hit. So no need to trim this sequence, but here you can see you are having a RNA PCR primer index 1, right? Which is rather than the no hit. So we have to trim this sequence. This is hampering the quality of the data. And that's why here it is represented as a red cross mark. Okay, if I will go a bit down, one more sequence we are having, which we have to trim it. And that you can see it here. Again, possible source rather than the no hit means what? You have to trim it, and this sequence also we have to trim it. And due to this two sequences only, we are having this cross mark. So we cannot neglect that. We have to trim that sequences. Is that clear? Which sequences we have to trim and why it is representing the red cross mark? If any doubts are there, you can ask me. Okay, okay, fine. So can you please check it out for the reverse file? I have told you yesterday only. Run the quality step for the reverse file also. So check it out how many overrepresented sequences are there in your reverse file that we have to trim. Okay. I just want the final count which should be trimmed. That sequences should be trimmed from the reverse file. Okay. I'm waiting for your responses in the chat box. Okay. I'll check it out. What about the others? Pritesh sir, Piali ma'am. Okay, okay. Yes, that's a correct answer. Here you can just open this HTML file for the reverse data also. Check out the overrepresented sequence and here you can see again. Here we are not having the no hit means what? We have to trim that sequence. So this is the one. And below also we are having one more sequence which we have to trim. This is what the second one. Right? So how we are going to trim it? So that I will tell you in the next step. Okay? But then don't ask me which sequences you are taking it, okay? In the next step. These things we will be trimming out in the next step, okay? So let's move to the next now. I hope like if I'm explaining the parameters over here, you will be able to understand it in the reverse file also. So I will not tell you the reverse file repeat again. Now here, the last important parameter we are having as a adapter content. Again, adapter content is what we are adding the adapters while performing the library preparation. And these adapters are not already present in our data. We are adding it outsidely, right? So that's why these adapters also should be trimmed. Now what happens? Whenever your sequencing platform will give you this sequences or the raw data, they will actually trim that adapters, but sometimes maybe these adapters can be present over there, so that you can see it here in the last important parameter. Now here the adapters are we know that adapters are platform specific, right? Illumina will be having a separate adapter, then we'll be having like solid will be having a different adapters. Likewise different platforms will be having a specific adapters, right? So if any Illumina universal adapter is present, here they will show you in the red colored graph. If your solid adapter is there, solid platform adapter is there, they will just represent it in the pink color graph over there. Now here in our data also we are having some adapter content, which is shown here. You can see it's a blue color, right? Means it is having the Illumina small RNA 3' adapter. So again, this is most important parameter, so we have to trim that adapter because it's outside sequence. And as this adapter content is there, so that's why here yellow exclamation mark is given. Again, it's having the moderate quality, but we will still trim it. Okay, I will show you how to trim this adapter content also. Okay, so I hope till here the things are clear. If any doubts are there, you can ask me now for the fast QC. Okay. Okay, so can we go to the next step now? So yes, now can anybody please tell me what will be the next step? We are having the third step now. Step 3. What will be the step?
Ma'am, trimming the overrepresented sequences.
Exactly, yes. Overrepresented sequences or adapted content, we are going to trim it. Or maybe if you are having the bases which are having the less Fred quality score, that basis also we can trim it out with the help of next step. So yes, we are performing the next step, which is what? Trimming and cleaning of the data. Raw data, you can say, using FastP. Okay, you can use FastP, you can use CutAdapt also. CutAdapt, I'm going to tell you in the next application, maybe in the reference based RNA-seq. I will tell you the CutAdapt command, or maybe if we are having more time, because tomorrow also we'll be having the trimming concept. So tomorrow, if some time will be there, I will explain you the CutAdapt also. Okay. So yes, let's first of all perform the fast pay, because fast pay is also used, like it's easy to use. Okay, like no need to add a lot of options in the command. So that's why first of all understand the fast pay, then we will move to the cut adapt. And if you are having any idea about any another tools, you can use that tools also. It's totally your choice. So if you haven't installed this fastp also till now, you can install it by sudo apt-get install fastp. And you can check the manual also. If it is installed properly, then manual will open. And if it is not installed, the manual will be not open. It will throw the error further, right? So now let's try to check it how we are going to use this fast way, which options we can use for that, right? So now it's your turn. Tell me, how can I open the fastp manual, which command I have to run it? Tell it to me in the chat box and direct message to me, not for everyone. Okay, okay, okay. It should be in the smaller cases, right? Yes, that's correct. Now let's try to open the manual and let's try to generate the command for the fastp. So here I'll open the WSL from the raw data folder, select the path and open the WSL. Maybe to open the manual for the tool, you can open this WSL from any folder. Okay, from any folder it will open. Let me clear it first of all so it will be properly visible to you. Yeah. Now, if I'm just typing the fastp, you can see still the manual is opening, right? Either you can use fastp hyphen help. Otherwise, if you're just typing the fastp, that is also working properly. Okay. So now here you can see we are having this version is also displayed and usage is also provided over here. So we just have to run the fastp command. First of all, we have to call the tool and then we can use a different options. Now, which options we can provide it over here? So first of all, we are having this hyphen I. So if you remember, in this DNA-seq, we are having a paired end data, right? If you are having a single end data, then you can just provide the input and output with the help of hyphen I and hyphen O. But as we are having a paired end data, means we are having two input files with us, right? So the forward input file, we can provide it with the help of -I option, and whatever the trimming will be done from that forward file, that output you can represent in the -O. Okay, hyphen small I, it is used to represent the forward input file, and capital -I is used to represent the reverse input file that we are having it. And after the trimming, whatever the results will be written in another file, that outputs you can provide it with the help of small -O and capital -O. Small -O for the output file of forward file, and capital -O, it is output for the reverse file. I hope till here the thing is clear. Then here we haven't mentioned, like here we are just providing the input and output, but what thing we want to trim, that we haven't provided yet, right? So what you have to do for that, so as I have increased the font size for this terminal, so that's why this manual is not displaying properly, but you can just check this thing out into your system also. So basically here you can see, if you want to indicate the Fred quality score, if you want to provide the Fred quality score cutoff, so here you are having the different options for that. Then here if you will see, we are having the adapter sequences, right? So basically, if you're providing one adapter sequence or the two adapter sequences are there, you can just mention it with the help of these options. But as most of the time, if you're having a lot of adapters, then you can directly provide the file for that, and that you can provide it with the help of one option as adapter underscore FASTA. This one, specify a FASTA file to trim both read 1 and read 2. Okay, so this option we are going to provide, and in this option we are going to provide the file in which we will mention all the sequences which we have to trim it. Is that clear?
Ma'am, can you repeat?
Okay, so basically here we have I have told you about these options. Okay, hyphen small I, hyphen O, hyphen capital I, hyphen capital O. That should be clear. But from this input files, what thing we have to trim it, that we haven't mentioned it yet in our command, right? So that outside sequences or the adapter sequences, we can mention in one note, like you can create one FASTA file in which you can provide the sequences, all the sequences which you want to trim from your files. And that file you can provide as an input with the help of this option, adapter underscore FASTA. Okay. As and when we will create the file, we will run the command, it will be more clear to you. First of all, let's create it, and then if any doubts will be there, you can still ask me. Okay. Maybe you can check it out the options for the threads also. You can see you're having the option here as a -W. So it's totally your choice which another options also you want to use it. Okay. So
Excuse me, ma'am. This FastP is not installed. Actually, we have to install it, right?
we have installed it, I think. You can install it by sudo apt-get install fastp.
Okay.
Yeah, you can try to install it right now only. Okay, you can just run the command, and I'm just generating the command right now then. So let's call the tool first of all fastp. Then we are going to provide our forward input file with the help of small -I. So what is our forward input file we are having? This is the one, isn't it? This is forward input file. Copy the file name and paste it here. Then for if the data from this file will be trimmed, it will be written in another output file, and that you can mention it with the help of small -O. And you can provide the name according to your choice. It's totally up to you what output file name you want to provide. I'm just providing the output file name as fastp and that ID. Okay. Just to understand that, that is what my fastp output. Then I can mention the reverse input file with the help of capital -I, and then I'm going to provide my reverse input file. Okay, then let's mention the output file name also for the reverse file. So again, I will mention it by fastp and the file ID of that particular sample. Okay. Then I have told you we are going to trim that sequences, right? Here we are having these overrepresented sequences with us, right? This sequence we have to trim it. We are having one more sequence below in that overrepresented sequence, and we have to trim this adapter also, which is Illumina small RNA 3' adapter is present in our data. That also we are going to trim it out, right? So three sequences we are going to trim it out from the forward file, and I think three are there in the reverse file also. So overall, in both of the files, you are having the 6 sequences. So instead of providing that 6 sequences in the command, we can write that all sequences into your FASTA file, and that file we can provide it. And how you can provide it? With the help of one option as -adapter. Adapter underscore FASTA. And after the space, you can provide that file name. Okay. So first of all, let's create, like I will be creating one file by the name of adapter.fasta. And in that file only, I will mention the sequences which I'm going to trim it out. Okay. So how can we generate this FASTA file? Can anybody please tell me the command? How can I create the file? Touch, exactly. I'll use the touch command and then create the adapter.fasta file. And here you will see my adapter.fasta is created. Let's open it. And here in this adapter.fasta file, we will mention the sequences one by one from both the files, from forward and from reverse file. So we know that in actual, like FASTA sequences are represented how, like greater than symbol. And maybe here I will write sequence one. Okay, in a description you can write it down. And then here in the second line we are going to provide the sequence which we are going to trim it out. So let's copy the sequences from the forward file fastqc report and overrepresented sequence. Now here you can see the first sequence we are having this one. So copy it, paste it here in the FASTA file. Okay, then provide the sequence 2 and mention the second sequence, which we are going to trim it out. So no hit is there, means no need to mention that sequences. Yes, but here you can see we are having this sequence which we have to trim it. So I will copy that sequence and mention it here. Okay, till here, if anybody is having any doubts, you can ask me. And these commands are, you are going to generate it by your own. Okay, I'm not going to share this command right now with you. Tomorrow I can share, but today you are going to run it in your systems also. Now, here from the forward file, we just have mentioned the overrepresented sequences. Now, one more sequence we have to trim it, which is adapter contained, right? So, what is that adapter contained? It's Illumina small RNA 3' adapter. But we have to mention the actual ATGC content of it, isn't it? So, how you are going to find out the ATGC content for that? That is one question again, isn't it? So whenever you want to find this adapters, whenever you want to mention the adapters, you should have one input with you. Maybe I will share that sequences with you. You have to download the sequences from the FastQC. If you're not able to remember that, that's totally fine. I will directly share the adapter content with you. So here, in this FastQC Babraham Bioinformatics link, you will be having the source code for the FastQC tool. So from here, you can download that FastQC tool. Okay. And if you will open that, already I have downloaded. I'll show you here only. Here you can see I'm having this FastQC. So if you will extract it, like if you will download and extract that source code of the FastQC tool, so in that tool, you will be having the configuration. Okay. And inside this configuration, you are having the adapter list over here. Okay. And this adapter list will be having this adapter content. So if you're in your FastQC report, if you are having this Nextera transposes sequences, means what you have to mention this sequence in your adapter FASTA. If you are having Illumina universal adapter, means you have to mention this sequence. Okay. Common for all. Yeah. Same for all means what? These adapter contents are universal actually. Yeah. So maybe instead of downloading the source code again and again, what we can do is I will share this adapters with you in the chat box. If you are making any notes, try to copy paste this adapter sequences into your notes. Okay. Or else one more thing I can do is I will share this file with you in the chat box.
Ma'am, can you show how to download this?
Okay. Okay. I will show you. No problem. Okay, I'm not able to actually share this file. Okay, I'll show you how to download it. So here, you just have to go to the browser and just type FastQC download. The Babraham Bioinformatics link you're having. Click on the download now. And then here different links are being provided, but we have to go for this FastQC, right? So according to your system distribution. If you're having Windows or Linux, you can download this. If you're having Mac, DMG image, you can download it. Okay. So if you're having the Windows, I'm directly sending you the link in the chat box. You can directly download with help of that link. Okay. And then which options I have chosen? After downloading it, you have to extract that folder. In the configuration, you're having the adapter list. Right? So now let's try to move to our command again. So in our, shall I complete the command? Then you can also try it out. Okay?
Yes.
Yes. So in our forward file, we are having this blue colored graph means Illumina small RNA 3' adapter. So let's copy that Illumina small RNA 3' adapter sequence from here. Copy it and mention it in your adapter FASTA. Okay, so these are the sequences from the forward file. But if you remember, we are providing the forward and the reverse file in one go, in one command only. So that's why in this file only, we have to mention the sequences from the reverse file also, which we are going to trim it. So sequence 4, we are going to mention. Let's open the FastQC report for the reverse file also. And let's try to mention that sequences. Generate your commands also. I'll copy it from here, paste it. Then sequence 5. And here you are having the red colored graph, means it's a Illumina universal adapter. So let's copy the Illumina universal adapter and mention it in your adapter.fasta file. I have written down all the sequences which we are going to trim it out. Save this file, and this adapter.fasta file should be present in your raw data folder so that your terminal will be able to identify that file, right? So here my file is ready, my command is also ready, right? So what I can do is I'll copy this command from here and I'll run it in the terminal. Okay. So now you can see it's blinking, the process is running. So try to create your own commands, and if any doubt is coming, if any error is there, please let me know. And do not make any spelling mistakes in your command. Otherwise, it will throw the error again. Let it run, it will take some time. Okay, I'm waiting for your doubts in the chat box. You can see my output is generated. Whatever the things it is showing, no need to worry about it. It shouldn't throw any error only. Okay. Without error, my process is done. My next path is coming. Means what? My trimming part is done. And here you can see my files are generated. FastP files are generated. Okay. So run this step into your system and let me know your doubts or the if errors are coming.
Ma'am, can you show the command?
Okay, here you can see it. Is it done? Are there any doubts?
No,
I'm
ma'am.
sharing this command in the chat box. Maybe you can take a note of it. And yes, then that's it for today from my side. I will show you here. You can see this is how the output files are generated. We will perform the next step tomorrow. Okay. So yeah, then that's it for today. Let's meet tomorrow for the next part.